So Apex Research Scholar Program, week 4. And this week we're going to be talking about data analysis and critical thinking. So week 4 overview. The first thing we're going to be doing this week is talking about qualitative versus quantitative data. And then number 2, interpreting results. And then number 3, research limitations. And then number 4, evidence-based conclusions. So where we are in this program. So we've been together for 3 weeks, and this is now the 4th week where we're going to be talking about data and analysis. And then week 5 will be the writing and communication, and week 6 we will present the research project. So what is data? Data is any recorded information used to answer a research question. Data can be numbers, words, images, audio, behavior logs, or text. The type of data you collect must match your method. So we have primary data and secondary data. Primary data is data you collect yourself directly from participants. It brings more control and there's more effort. Some examples are survey responses, interviews that you conduct, or your own experiment results. And then secondary data. Secondary data is existing data that's collected by other people. It's faster and often larger scale, but there's less control over how it was collected. Some examples are census data, data sets that we can find online, or even school records, but with permission. So qualitative versus quantitative data. So quantitative data is numbers that you can calculate with. For example, survey ratings, which could be on a 1 to 5 scale, test scores, temperature, or frequency counts. And they could be analyzed with statistics, like averages, correlation coefficients, or regression. And its strength is that it's precise, it's replicable, and it's comparable across large samples. But the limitation is that you may miss nuance, context, or human experience. An example of quantitative data is 62% of surveyed students report sleeping less than 7 hours on school nights. And then qualitative data. This is words, themes, and descriptions. And you could interview transcripts, could be interviewing transcripts, open-ended survey responses, field notes, and documents. It can be analyzed with coding by identifying themes, patterns, and categories. And its strength is that it captures meaning, complexity, and lived experience. The limitation is that it's harder to generalize and it's subject to researcher interpretation. One example is students described feeling exhausted and unable to focus when school started before 8 a.m. So mixed methods, using both types. Many strong research projects use both types. Quantitative data shows the pattern, but qualitative data explains why the pattern exists. Example 1. Quantitative data could be a survey, and it could say 68% of students reported using phones after midnight at least 3 nights per week. A qualitative, which could be an interview, might say, I cannot stop. I feel like I will miss something important, which is the fear of missing out or a parasocial connection. And quantitative data identifies prevalence, but qualitative data reveals psychological mechanism. So example number 2, quantitative data. It could be an analysis of an online data set, which says schools with extended library hours show 12% higher graduation rates. But qualitative data might say library described as the only quiet place to focus in under-resourced schools. So based off of this, quantitative data shows correlation, but qualitative data provides the causal pathway hypothesis. So interpreting quantitative results, the mean, which is the average, it's the It's the sum of all values divided by the count, but it's sensitive to outliers. For example, the mean of a GPA is 3.12, but one student with 0.5 pulls the average down significantly. The median. This is the middle value when data is sorted. It's resistant to outliers and it's better for skewed data. For example, the median household income in a data set is more informative than mean when there are billionaires. Correlation. This measures strength and direction of a linear relationship. It ranges from -1 to +1. Um, and then statistical significance. It's the probability the result occurred by chance. And then effect size. How large is the actual difference or relationship independent of sample size? Interpreting qualitative results. Qualitative analysis is systematic, not subjective. Follow your process. Compile, compile, or yeah. Number one, transcribe slash organize. Compile all responses, interview notes, and documents in one place. Format consistently. Number two, open coding. Read through the data and label segments with short descriptive codes, for example, anxiety, social pressure, lack of sleep. Number three, axial coding. Group related codes into categories, like anxiety and social pressure and FOMO may group under psychological drivers. And then number four, identify themes. Themes are just patterns that appear many times throughout participants and data points. And then number five, quote selection. Choose actual quotes that illustrate each theme. One strong quote will always beat five weak ones. And then number six, interpret what do these themes tell you about your research question and connect patterns back to the original question and literature.
Okay, so when you look at your data, there's actually like four things that you should be try to like take out when you go to your data. There's actually three things. Two of them are really similar. The first two that are similar are trend and correlation. Basically, at the end of the day, when you have these data, like i.e., like you check if like does the amount of sleep that a person or student gets correlates to the amount of grades that they like, how good or bad their grades are, then you could see like if there's a positive correlation and negative correlation, a positive over trend or like a negative over trend. It's basically just a directional change in like over time and across categories. Then in the specific like two types of correlation trends, you have two different things. You can decide if there's outliers, i.e., like if you get a little bit sleep but you're scoring 95s and 96, that's considered an outlier because it goes against the trend of if you're getting a little sleep, then that means you're getting less grades. In other words, it doesn't really match the correlation that is going with you or like what you predicted, which is why it's an outlier. Then the other one is like a null result. Basically, a null result is like a hypothesis. You give a hypothesis in the beginning before you do research, and at the end of the day, if your like trend does not, or your trend or correlation just does not match your hypothesis, then you just say, oh, it's a null result because there's no pattern found whatsoever. So that's why there's really three ways once you draw your evidence you should be able to concluding. First, you should be able to answer your original questions. So you should be avoiding questions like my data shows many interesting negative trends in adolescent behavior. Instead, you should be phrasing it so it includes some numbers, i.e. it shows like a negative correlation of like negative 4.8, which is just like like don't worry about the R equals. That's just like a statistical thing. But at the end of the day, just know like you should be able to clearly describe the trend that you're seeing in your pattern. That's why the second thing, when you're describing, you have to be able to use precise language, i.e., like social media like significantly associates with less sleep quality of like is associated with worse sleep quality. It does. You just don't say social media clearly causes bad sleep. You have to explain like you have to like take it one step further because that's really shallow and you don't show the causation. That's why you have to acknowledge what you did not find. Like, yes, you have all these conclusions on how like this or this does not help your hypothesis, but at the end of the day, you also have to acknowledge what you didn't find, such as, or it's like you shouldn't just say like our hypothesis is completely proven. There's all like no way in the world is something 100% completed. That is why you have to like. There's always stuff in the world or stuff in studies that does not support your hypothesis, so that should be also included in your conclusion. So, also, you need to understand that correlation does not imply causation. Just because one thing goes up and the other thing also goes up does not mean that the other, like that, like, wait, just because item A goes up and item B goes up does not mean that item A causes item B. They can both be going at the same time, but that does not mean that one causes the other. So there's also like multiple mistakes that a lot of students do. First is that they cherry pick results. You should not be cherry picking results in your research. You should be generalizing your results and see like, oh, like what how this or this does not support my hypothesis. Because just remember, at the end of the day, when you're doing research, you don't have to be 100% right. That is the whole point of doing research, to see if your hypothesis is right or wrong. That's why also you should be able to generalize from a small sample size. You should not like generalize your research over like small samples, because these are like really things that are addressed with AP statistics. But at the end of the day, when you have a small sample size, you have a higher chance of being biased with your sample, and you really like you need to have your sample random, and you need to be able to have the sample where it addresses the whole population and all the traits of the population. Then like you shouldn't have like confusing statistical significance with importance. like like you should be including important stuff, not really trivial small effect stuff. Oh, sorry. That's why you should not address like alternative explanations. You should just say that like, oh, like this evidence supports my data, this evidence does not support my data. That's basically it. Like reject the whole null or like accept the null. That's why you should just like let your hypothesis be the center of your research. So, like, when you look at research, you have a lot of limitations. There's actually four. The first one is self-report bias. When you take a survey, you actually have a lot of like, you have to follow a lot of rules to make sure that your survey is accurate and it is random. So it actually addresses the true population and there isn't any skew in your results. There's actually four things that actually causes this skew. The first one is self-report bias, which is where participants like not accurately recall or may like represent their misrepresent their behavior, i.e., like if you're doing a survey and the people you're like surveying is talking like lying to you or giving you wrong information, that really skews results. So try to avoid that. Then like you should be aware of confounding variables. This could be like unmeasured third variables, like could explain your results. So make sure to like limit those. The next one is like having a small sample, because think about it, like if you have like a question, like I know Effie like was researching about like well, reading, right? Reading, like reading scores with children in her grade. Like you shouldn't just be measuring like surveying about your school. You should be going out to other schools and surveying, because problems that exist in your school might be different and might affect like the hypothesis differently compared to other schools, which is why you should have multiple big samples that just aren't like clustered around one trait. And the next one is just cross-sectional design. Like you measure like one snapshot at a time. You cannot like see change over time. You have to like have a like overall time period when you do these samples. So what your findings should look like, you should actually have a mix. Your quantitative findings should be saying like you have this correlation of X, Y, Z, and it's either really strong or really poor. Then you should also have qualitative findings that back up these quantitative findings, i.e., like if your correlation is really high and really strong, then you should say, oh, here's some student examples that show how these correlations are strong. So these are like the mentor breakouts, like analysis and troubleshooting. So in your track group, you'll work through these data with your mentor. So there's actually five things. First, you have to collect your data. I'm not sure if you guys have already. I think that's what our plan is for today's meeting, is to try to figure out ways to collect your data, maybe research a little bit. And then you should talk to your mentor, see if that path is good. Then you should be like you should confirm your analysis method again. Just talk to your mentor, see if that track is good or like that plan is good. Then you should be like identifying these. Like once you get your data, you should be trying to put together patterns and see like what happens because of this, or like what is correlated, what is caused, blah 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 blah. That really just looking at your data and seeing what patterns are emerging from that. Then you should be looking at your limitations and seeing how to overcome your limitations. I just talked about the limitations on the last slide, like having a like sample size over a small time period or a small sample size. You should be looking at your limitations and seeing how you should be able to overcome that. And if you've already done your survey or already collected your data, then you should be figuring out a way in your research on how to address those limitations. And then at the end, you just draft your findings and then show it to your mentor. So the analysis tools. So for life sciences, you could use like Google Forms, like Google Sheets. For like CS and AI, you could use like Python, anything related to computer science. For mathematics and data, you could also use Python. You could actually use Desmos too. Like at the end of the day, like Desmos is a math calculator that helps you graph data points and cluster data points, and it just shows you the correlation between two different variables. For social science, you could use like Google Sheets or Excel, and humanities, you could use like coding softwares, and you could be setting out those Google Forms. But those are just also quantitative. Remember, qualitative is like interviews, so you shouldn't just be restricted to only these type of tools. So, when you're challenging your own work, you have to be thinking about a few things. First, you should be thinking, is my data actually answering the research question? That's why, to answer this question, you have to reread your original question. Does the data you collected actually address it? The second one is, did I measure what I actually wanted to measure? Because at the end of the day, research is a long process, and you could actually just go off path and start researching about completely random things that aren't your research question. So just look back to your research question after you're done like finding and collecting your data. Just look, did I actually measure what I want to measure? Then you should be asking yourself, are there alternative explanations I have not considered? This happens when once you've collected your data, you should be looking at your correlation and causation effects and seeing, oh, okay, this is what I have had, this is what I conclude. Is there anything else that I'm not missing, or any other explanations that also can be correlated with this graph? Then fourth question is, would my sample look different? I'd study different people. In other words, like if you surveyed one school and you got a certain amount of data, would that data look different if you surveyed another school? That is why the best way to counter that is actually having a big population in a big sample with multiple different schools and multiple different like areas. It's not just clustered in one. Then the fifth one is, is my conclusion stronger than my evidence, and does it actually support it? Just again, look at their data and then look at your hypothesis, see whether you should be rejecting your hypothesis or accepting your hypothesis. So these are just real examples of how findings look like. This is 2018. He said like each additional hour of electronic device use was associated to 3 or 4 minutes less sleep per night with a national representative U.S. sample of 36,577 adolescents. This is really perfect. You can like read through the next ones, but I'm just going to talk about this one because this one is really perfect because when you look at the conclusion, it's really like it's concisely written out, but at the same time, it hits the main points about the statistics that you get or they get in their conclusions. And on top of that, it also has the big sample size. It's not just restricted to a small amount of people or a certain area. And it's not restricted to a certain area because it talks about the U.S. in general. And on top of that, it like ties back with its hypothesis of like electronic device associated with sleep per night. So this is the week 4 that you should be this is what you should be focusing on week 4. For if you're going for like a quantitative mixed studies type of approach, you should be having a data summary table or a chart that you should show your mentors to show that you're working. You should have key statistical values such as means, correlation, p-values, all the things that Josiah was talking about. Then you should have 2 to 3 sentences just explaining what you have concluded after finding your data, and then also having a list of limitations that affect your data. If you're going for like the qualitative type of research, you should be identifying themes that happen across all your like sorry, all your people that like, i.e., like if you're doing qualitative data, you should like a main thing that you do is interview people. So you should be like identifying themes of who, like what themes emerge after interviewing each single person. Then you should have like a summary of these patterns across these different types of sources. That's why then you link it back into like how that helps your argument and how that helps your statement. So